Hi, in this chapter, the bolts, nuts, and screws, the last lesson. In this last lesson, let us discuss about the proportions of bolts and nuts, design of bolt and nuts, and these two topics we are going to discuss in this lesson. Let us say on the completion of this lesson, we should have the following objects. We should have the concept of following objects. On completion of this lesson, we you would be able to calculate proportional dimensions and sketch of hexagonal headed bolts and hexagonal nuts. And next is square headed bolts, square nut by using empirical relations. Design a hexagonal headed bolts and hexagonal nuts. Design a square headed bolts and square nut by using empirical relations. And all these concepts you should have in this lesson. You should learn from this lesson. Right? Let us see one by one. So now here you can see a nut or a screw and a bolt comprises screw pair. Screw pair. There are some types of pairs are there in mechanisms. Among these pairs, screw pair is one of the pair. That means lower pair, higher pair, screw pair, etc. Different types of pairs are there. And here in this, we are having screw pair. So this pair is used for fastening, right? So among many types of pairs, as I told you, lower pair, higher pair, screw pair, and different pairs are there, which might have discussed in basic link mechanism topic. So now here these nut, screw, and bolt comprises a screw pair, and this pair used for fastening. Right here you can see the screw pair, that is hexagonal headed bolt with a nut, and here it is consisting of one head which is in the shape of hexagon, and there is a shank up to this point, and which is of nominal diameter, and also a threaded portion. At the end of the threaded portion, we are going to have an hexagonal nut. And in order to join two parts, and most commonly in the market, in engineering field, we are going to use, and comparing to the other types of bolts, we are going to use hexagonal bolt most commonly. Here you can see this one part to be joined and another part is to be joined, and this is the head of the bolt and this is the nut. So in this way this becomes a bolted joint of two parts to be joined, right? So friends, and what are the types of bolts? There are so many types of bolts are there. Among these, let us see hexagonal headed bolts, which is the most common in the market. And now let us see and the square headed bolts next to the hexagonal headed bolts, right? Next is cup headed bolts and T headed bolts, countersunk headed bolts, cylindrical or cheese headed bolts. And all these are the different types of bolts. One is hexagonal headed bolts, two is square headed bolts, three is cup headed bolts, and another is T headed bolts, and countersunk bolts, countersunk headed bolt, and the cylindrical or cheese headed bolts. These are the six types of generally we use in the engineering field. and machinery field also. Along with this, with these different types of bolts, we are also going to use different types of nuts. So let us see hexagonal nut we are going to use, and also which is the most common type, and also square headed bolts, sorry, square bolt, square nut, hexagonal nut, and square nut, and then and some special purpose nuts are there which we are going to use wherever we need. Number one is flanged nuts. That means it is similar to the hexagonal headed nut, but only the bottom is just like a washer is connected to the, it may be a flange, it becomes a flange, a washer is connected to, in connection with this hexagonal nut is there, that is called flange. And similarly, and a cap nut, it is just like a cap nut, and dome nut, and a capstan nut also, ring nut, which is generally used in case of stove, etc. We are going to use in many other cases, and wing nut. So these are the different types of nuts are there, and mainly we use hexagonal nut and square nut most commonly. Among square and hexagonal nut will be used most common, right? Previously, in the bolts, where mostly we use hexagonal bolts, and in case of nuts, mostly we use hexagonal nuts, which is in the shape of hexagon, right? So these are the different types of nuts and different types of bolts. Okay, as per our syllabus, we are having only square and hexagonal bolt and nuts. So see, as per our syllabus, we are going to discuss only about hexagonal headed bolts and hexagonal nuts, right? And we are going to also remember all the proportions of hexagonal headed bolts as well as the hexagonal nuts, right? And how to design all these bolts, and what are the empirical relations of these bolts and nuts. And also we are going to discuss all these in this lesson, and only we are having hexagonal headed bolt and nuts. And also along with these hexagonal headed bolt and nuts, we are also having square headed bolts and square nuts, and these are there as per our syllabus, so which is also one of the important from even examination point of view. So let us see, this will be the hexagonal headed bolts and also hexagonal headed nuts. So let us see, this is the hexagonal headed bolts, and this is of hexagonal shape head, and this from here to up to this point, this will be the see shank, and this will be the shank threaded portion. And from here to here it is the root diameter, and then from here to here it is the nominal diameter, right? So let us see the proportions in this are, this will be the length of the bolt, and this will be the height of the head, and that means the shank diameter or nominal diameter of the bolts is d, and height of the bolt is generally 0.8, whereas the corner to corner head distance is 2d, whereas face to face is 1.5d plus 3. And these proportions we must remember. And also we should also know this length of threaded portion. So let us see what are the empirical relations we are having for this. So this hexagonal head bolts and nut are the most common form of bolts, right? Next is hexagonal head, the chamfered. Here you can see this is chamfering, right? At its upper end. That means this part is chamfered, right? Next is to prevent rotation of bolt while screwing. That means this is chamfered, and also it is in the shape of hexagon only to prevent the rotation of bolt while screwing the nuts on or off. That means screwing into the nut or unscrewing of it. The bolt head is held by another span, right? So this is a small information about hexagonal headed bolts. Next is what are the proportions? Standard proportions of hexagonal nuts. Here you can see this is the from corner to corner E, and whereas the face to face of hexagon, this is the distance. So this is also same, whereas this is the height of the nut, and this will be the alpha will be the angle, chamfer angle, and this will be the radius for nut. So let us see size across flats. That means size across flats means from here to here. Size across flat means from this is one flat and this is another flat, and the distance from these, that means S, will be, you can see 1.525D, where D is the nominal diameter of the bolt, plus 6. This is generally we have to use as per the standards, or sometimes we may also under prop 3D. This is size across flats. Next is size across corners E. It means you can see from corner to this corner to this corner, or here to here, or here to here. And what will be the size? This is also you must remember. So this will be the 1.155 into size across flats, 1.155 into S value. That means you should know the calculation for size across flats. With that you can have 1.155 S we are going to have, right? So this is size across corners. Next is height of the nuts, as we have discussed in the previous, and this will be the 0.8 to 1D. 0.8 to 1D. And generally always the chamfer angle will be 30 degrees only. 30 degrees only. And the radius of chamfer arc. The radius of chamfer arc means here you can see this is the radius of chamfer arc, and this is the radius angle alpha. So you can see chamfer arc radius is 1.5D. 1.5D. That means size across flats S is equal to 1.25D plus 6 or 3D, under root of 3D, and size across corners E is equal to 1.155 into S, and the height of nut is 0.8 to 1D, chamfer angle 30 degrees, and chamfer arc radius is 1.5. And these proportions we must remember, and also these are the standard proportions. And next is similarly same as the bolts, standard proportions of bolts, hexagonal headed bolts. Here you can see once again from corner to corner head. This will be the head, hexagonal headed, and this is chamfer angle, and always chamfer angle will be 30 degrees. And size across the flats, yes, similarly, same as in the previous case, size across the size from corner to corner, this will be the E, same as in the previous nut, and this H will be the height, and L will be the length of the bolts, and small l will be the length of the threaded portion, and D will be the nominal diameter. Let us see the proportions. The sizes of head are same as that of the nuts. Similar, that means S is equal to 1.25D plus 6 or under root of 3D, and E is equal to 1.155 S. same in the previous. And also height of the head is equal to 0.8 to 1d. The chamfer angle will be 30 degrees. And also so you can see in this same as the nut we are having, but height of the bolts head is taken as 0.75d to 0.8d only. Whereas the previously the height of the bolt is 0.8d to 1d, but now here it is 0.75d to 0.8d, and the length of the threaded part is equal to L is equal to 2d plus 5 mm for a bolt up to and including 80 mm. For a bolt up to and including and similarly 2d and the same length, the length of the threaded part only, threaded portion only. So this is the threaded portion length. So this will be 2d plus 10 mm for bolts length above 80 mm and for bolts length 80 above and up to 200 mm, and 2d plus 20 mm for lengths above 200 mm. Okay, these are the length of the threaded parts. So height of the 0.75d, height of the bolt head is equal to 0.75d to 0.8d, and these proportions we must remember. So now let us see. So far we have completed only hexagonal nut as well as hexagonal headed bolts and a hexagonal nut, and from flat to flat it is 1.25d plus 6 or under root of 3d. In corner to corner it is E. E is equal to 1.155 S, and the chamfer height is equal to height of the nut is equal to 0.8d to 1d, whereas chamfer angle will be 30 degrees, and then hexagonal head bolts proportions will be same as the hexagonal head nut, and only the length of threaded part is equal to up to 80 mm one value to 2d plus 5, and up to 80 to 200 2d plus 10, and above 200 it is 2d plus 20. Okay, so now let us see the square headed bolts now. Square headed bolts generally used when the head is to be accommodated in a recess, and this will be used, and this is the shape of square headed bolts. So here you can see height of the bolt is equal to 0.8d, and radius of the chamfer will be r, and d will be the nominal diameter, L will be the length of the threaded portion, and from flat to flat size across the flats is equal to 1.5d plus 3. So this recess also is made of square shape so that the bolt is prevented from turning. The recess is made in the shape of, that means this is generally used to accommodate in recess, and the recess is made in the square shape. It means in the square shape so that the head will be automatically seats within the recess its own. Thereby, it will prevent the turning or rotation of the bolts. So that is the main idea. So this recess also is made of square shape so that the bolt is prevented from turning when the nut is screwed on or off it. And commonly used in bearings for shafts. These are commonly used in bearings for shafts Generally we can see these type of bolts in plumber block, that is pedestal bearing, where we can see simply these types of square headed bolts we are using in plumber block, or we can also call it as pedestal bearing. In such cases we are going to use these type of bolts. So so what are the proportions? As we have seen some of the proportions previously, from flat to flat is 1.5D plus 3, and the height of the head is equal to 0.8D. Whatever the length of the threaded portion, whatever the length of the bolt also we should have. So let us see, thickness of the bolt head is equal to 0.8D to 1.0D. This is the thickness of the head. And width across flats, width across flats is equal to 1.5D plus 3, and radius of chamfer arc is equal to R is equal to 2D, capital R is equal to 2D, and length of threaded portion L is equal to, here you can see in the previous case length of threaded portion is equal to 2D plus 5 up to 80 mm bolt, and 2D plus 10 mm from 80 to 200 mm bolts, and above 200 it is 2D plus 20. But now here it is in the case L is equal to 3D plus 5 up to 80 mm diameter. 3D plus 5, it is up to 80 mm diameter. And similarly 2D plus 10, same as in the previous case, but only the slight difference is 3D. And 2D plus 10 mm for up to 81 to 200 mm diameter. And the length of total length of the bolt here you can see 3D to 20D. 3D to 20D. So these are the proportions that we can see for a square-headed bolt. For a square-headed bolt. So all these thickness of bolts head is equal to 0.8D to 1D, and width across the flats will be 1.5D to 3D, and the radius of chamfer arc will be 2D, and length of the threaded portion is 3D plus 5 up to 80 mm diameter, 2D plus 10 up to 200 mm diameter, whereas the total length of the bolt will be 3D to 20D. In these proportions we must remember, where D is equal to nominal diameter of the bolts, right? So the standard proportions of square nut. So far we have seen square-headed bolt. Now let us see the square nut. So here also chamfer angle will be 30 degrees, same as in the previous case. Height will be there, and corner to corner E is also there, and flat to flat end. This will be the 1.5D plus 3. Anyway, we are having height is equal to point, maybe same as the previous case, and the size across the flats S is equal to 1.5D plus 3 mm, and size across corner in case of previous case it is 1.155, yes, whereas now it is under root of 2, yes, right? This is the value size across the corners of the square nut. And the height of the nut is equal to 0.8D to D, and the chamfer angle will be always 30 degrees. And these proportions you must remember for the design. So all these are becomes under standard proportions. And why these standard proportions are used means there should be some interchangeability, because of these are the standard components, and more frequently they may fail, That's why we are going to standardize all these dimensions. Thereby, we can interchange whenever one bolt or nut is failed, we can interchange with this new one. So that is the idea of having empirical relations to standard proportions, right? So let us see. So far, we have discussed about what is screw pay and also what are the types of bolts and what are the types of nuts also we have discussed so far, and also what are the standard proportions of hexagonal nuts and standard proportions of square nut also we have discussed so far, and also standard proportions for nut hexagonal bolts, the standard proportions for square bolts, and all these we have discussed so far. Let us have simple problems on these proportions of square headed bolt and nuts and hexagonal headed bolt and nut. Let us see. So here is the problem. Compute the proportionate dimensions of hexagonal headed bolts. Here we can see hexagonal headed bolts having 30 diameter. And what is this diameter means? Simply it is the, here he has not mentioned either it is the core diameter or it is nominal diameter, but we can see simply we think that it is the nominal diameter. Don't go in any other manner. It should be always nominal diameter of the bolts, right? So thereby, based on this nominal diameter, we are going to calculate each and every proportion, of hexagonal headed bolts, and we can manufacture on the machines itself. So let us see. So given data is, among the solution first is given data, and this given data, in this given data, nominal diameter D is equal to 30 millimeters. Now, by getting this 30 millimeters of nominal diameter, we should calculate all the proportions. That means, what are the proportions here? See, you can see, number one is size across the flats of hexagonal head and size across the corner of hexagonal head and height of the hexagonal head, right? All these proportions we should calculate. Along with this, for the threaded portion, length of the threaded parts, and length of the threaded parts can be calculated based on the diameter only. That's why the length of the threaded part L is equal to 2d plus 5 up to 80 nominal diameter, and from 80 nominal diameter to 200 nominal diameter, then it will be 2d plus 10, as in the previous discussion. And similarly, 2d plus 20 is also available when the bolt diameter crosses the 200. So now our diameter in this problem, in this hexagonal bolt problem, we are having the nominal diameter only 30, which is less than 80 That's why we are taking L is equal to 2d plus 5 L is equal to 2d plus 5 Okay. So with this, you can calculate length of the threaded portion. So that will become 2 into 30 plus 5, which will become 65 This will be the threaded length portion, the threaded part length. So next is length of the bolts. Here you are having 4d to 20d. Any value in between these two, 4d to 20d. So among this, and this value 4d to 20d, 120 to 600 That means the length of the bolt may be either 120 mm or it may be also be 600 mm. 600 mm. Among this, you can, as per your convenience, you can take any value in between these 120 to 600. So next is size across the flats. Size across the flats S is equal to 1.125D plus 6R under root of 3D. This is the generally the size across the flats is equal to 1.25D plus 6R under root of 3D. So with this calculation, we are having 43.5 to 51.96 mm. Next is, say it may be rounded up to the next or higher value. There should not be any fractions. So 44 mm, whereas this upper limit is maximum only 50. So, and similarly, size across corners is equal to E is equal to 1.155s. Means if you take 44 or 52 or 50, 45, 46 up to 50 to any value, then this should be substituted in this value. Size across corners E is equal to 1.155 of this S value. Okay. So with these calculations, you are going to have either 50.24 to 60.01 mm. So any value you can take among all these values. So height of the head, and in this hexagonal headed bolt, height of the head is equal to, actually here is 0.75 D to 0.8. So this is the value that we are having. So that value may be 22.5 to 5D to 5D to 24. That means 22.5 to 24 mm. So chamfer angle, same as in the previous all cases, it is the 30 degrees. So chamfer arc radius will be 1.5D, that will become 45. So these are the standard proportions that we have calculated based on the given nominal diameter. One, we have the given only value is hexagonal bolt diameter, that is nominal diameter or shank diameter, whatever it is. So based on that, we are going to calculate the standard proportions from the standard data, right? So next problem, now it is the problem. If previously we had discussed only bolts, now let us see hexagonal nut. Hexagonal nut. Compute the proportionate dimensions of, second problem is proportionate dimensions of hexagonal nut having 30 mm diameter. As we have discussed previously, that value may be more or less whatever it is. The proportions may be more or less head values. So let us see. So nominal diameter D is equal to 30 mm, and same as in the previous case, size of across the flat S is equal to 1.25 D to 60, or also sometimes it may be under root of 3D, right? And the values obtained here are the standard values. And similarly, size across corners E is equal to 1.155 D into S. S means size across flats. So its value also from more or less 50 to 60 mm. The height of the nut is equal to 0. 80 to 1D, and that value may be 24 to 30 mm. And radius of chamfer arc is equal to 2D, whereas in case of hexagonal headed bolts, and that may be 1.5D. Now here it is the 2D. Chamfer angle will be 30 degrees. Chamfer arc radius is equal to 1.5D. So these are the values, calculated dimensions here are shown. And also now, so far we have completed only hexagonal headed bolts and hexagonal nuts. Now let us compute the proportionate dimensions of square headed bolt having 30 mm diameter. And similarly, for square nut also we have to calculate based on the same size. So let us see. So given data is only one dimension, that is nominal diameter 30 mm, same as in the previous problems, and thickness of the bolt is equal to 0.8 to 1D and 24 to 30 mm only. And the width across flats is equal to 1.5D plus 3. And this will be means 45 plus 48 will be. And length of the threaded portion here you can see L is equal to 3D plus 5D up to 80 mm, and our dimension is only 30 mm diameter. But here up to 30 mm the same formula we have to use for calculation of length of threaded portion. So here in this case let us calculate, this will be 95. And length of the total length of the bolt itself 3D to 20D and 90 to 600. So total length of the bolt may be adapted as in the 3D to 20D, and these are standard calculations for square headed bolts as we have seen in the theory part itself. And square nuts, compute the proportionate dimensions of square nut having 30 mm diameter. So let us see the same as the previous. Size across the flat is equal to 1.5D plus 3, and which will be the 48, and the size across corners is equal to under root of 2 into S. Here E is equal to under root of 2 into S, and thus may be 68. And similarly, height of the nut 0.8D to 2D and 24 to 30 mm, chamfer angle will be 30 degrees, same as whatever it is. And now let us see the calculated dimension may be posted in the figure itself. So whatever the dimensions we have posted, what is the S value and what is the E value, what is the height and the chamfer angle, all these we have to calculate, and also chamfer radius if necessary. So all these also we have to calculate and use. Right? Now let us see. So far we completed some design proportions of hexagonal headed bolt and also nut, and also square headed bolt and square nut, and some more problems we completed. Now what are the advantages of a hexagonal headed bolt and nuts? Let us see. Commonly used for general fastening purpose and more convenient to screw on hexagonal nuts than other nuts with spanner. That these are some advantages of hexagonal headed bolts and nuts. And also the spanner will have to be turned to get another hole is 60 degrees on. To hold the spanner, only 60 degrees is sufficient for holding. Whereas in case of square headed bolt, it needs, in order to hold the other side, it should turn 90 degrees. But now here it is only 60 degrees we can turn. And advantage of square headed bolts and nut, used when head is to be accommodated in a race, recess only, recess only, and used in bearings for shafts also. That means, as I told already, plumber block, etc. Next is the spanner will have to turn to get another hold is 90 degrees. That means in case of hexagonal headed bolt, it is 60 degrees. Now, in case of square headed bolt, it is 90 degrees. These are some advantages. The spanner is used for turning, the nut can be better hold. And have it will give you the a square shape will give you a spanner to have better holding, right? And these are the advantages of square-headed bolts and nut and the hexagon-headed bolts and nut. So let us see once again the summary of this lesson. Summary of this lesson. Let us see. So far we have discussed two types of bolts and nuts. One is the hexagonal-headed bolt and nut, and square-headed bolt and nut, right? And also we should be able to calculate. Now, as per this discussion, we are able to calculate empirical dimensions and sketch of the hexagon-headed bolt and nuts and square-headed bolt and nuts. Right? So, this is all about the summary of this lesson. And next is so far two types of bolts. Now, let us have a small quiz. Whatever so far we have discussed, it is bolt types of bolts and hexagon-headed bolt proportions and calculations, and also square-headed bolt proportions and calculations. On this, let me have a small quiz. Let us have the upper corner of the hexagonal nut is rounded off to the upper corner of the hexagonal nut is rounded off to which angle? Either it is 90 degrees angle or 60 degrees angle or 30 degrees angle, whichever is the right answer, maybe 40 degrees. As we have discussed so far, that is the upper corner of the hexagonal nut, that is simply we can say chamfer angle. So 30 degrees will be the right answer, right? So next is chamfer angle of the square nut is 20 degrees to 30 degrees, 30 degrees to 45 degrees, and 45 to 70 degrees, and 75 to 90 degrees. Whichever is the right answer. Actually, that may be the 30 degrees, but it is there in the option A also, and it is there in the option B also. Whether the 20 degrees to 30 degrees is right answer, or whether the 30 degrees to 45 degrees is right answer. Let us see the chamfer angle of the square nut is. So 30 degrees to 45 degrees is the right answer. Right? So next is in case of hexagonal nut, the angle of spanner to be turned to get another hold. That means while turning a nut, and first hold is there, and to the another to hold, how much angle has to be turned the spanner. So as we have discussed so far, it will be 60 degrees only. Either it is 30 degrees, 60 degrees, 90 degrees, whichever is the right answer. Chamfer angle will be 30 degrees, but as it is the hexagonal shape will have each corner as 60 degrees only with the horizontal line. Thereby, the spanner has to turn only 60 degrees, right? So 60 degrees B is the right answer. Okay, and the last bit is, let us see, in case of square nut, the angle of spanner to be turned to get another hold, is, as it is a square shape and each corner will have 90 degrees. So the spanner has to turn, first hold is like this, and second hole will be 90 degrees. That means that we have to turn 90 degrees. So the right answer may be 30 degrees, 60 degrees, 75 degrees, and 90 degrees. Whichever is the right answer. As per our discussion, simply we can say is the 90 degrees. D answer is the right. So 90 degrees will be the right answer. So friends, today in this lesson we have discussed about uh, the design of hexagonal and square-headed bolt and nuts and their empirical relations also, and some simple problems and some quiz also we have completed. So thank you for patient hearing.